So hello everybody, this is now our SLHT 7 to 8 video for the two hypothesis tests that you are going to apply. So the first one is going to be about the t-test for independent means, and other one-way analysis of variance. So for those who have read the SLHTs, very good, and for those who haven't, very good Gapon, because you are here and watching this video. So most of the readings are there, and then let's just go over this. First, objectives. What are we going to learn for these two lessons? Before, we tried to learn about the concept of hypothesis testing, the different types of error, and also the different types of tests that we can possibly use in analyzing our data. So for this video, we will be describing the conditions on when to use the test called one sample, or the independent sample t-test, and computing that observed t-value you're going to solve, and then interpreting that t-value and understanding what it means. So first, review. Choosing between two-tailed or one-tailed tests. So I had questions from some of you asking, what are these two-tailed and one-tailed tests? So it is a matter of what you want to prove. So for this column, observe how the null hypothesis H sub O or HO, it says that a unit is equal to another one. So for a population HO, the population is equal to the population. Population 1 is population 2. They're just equal, versus the alternative hypothesis or the research hypothesis. For example, the sample mean is not equal to the sample mean that you found from another group. So sample mean 1 and sample mean 2, they are not the same. So that's just the null hypothesis should be rejected then when the test value is either in these two critical regions. So we have regions where we're going to say if it falls, if what we have solved, if the test statistic, because we are just going to look for test statistics and compare it with the critical value. And then if, for example, in this test, Z values, if the numbers that we found falls at these regions, that means we're going to reject the null hypothesis. So in this kind of test, we have two sides of this normal curve. This is a two-tailed test. So if it falls on any tail, that means we can say there is an evidence against the null. So there could be a difference, a significant difference. Whereas in this one, this is called a one-tailed test. Why? So there is one side. You can either say the other group is greater than the other, or the other group is lesser than the other for their alternative. So indicates that the null hypothesis should be rejected when the test value is in the critical region on one side of the mean. So for example, in these two curves, we have the left-tailed, because if the value that we solve falls in this region, that means there is a chance that it is not the null hypothesis the null hypothesis has to be rejected. So for the other one, if it falls on this side, if it's larger than this value, this is called a right-tailed, meaning you have evidence also against the null, but on the greater end. So it's just on how you have stated your your null hypothesis. Have stated your alternative hypothesis. So any of these two. If you want to check if there is a difference, you just use a two-tailed test. But if you want to really check if one is greater than the other or one is lesser than the other, this is a one-tailed test. It is very important to be able to identify because we are going to use this one in the first lesson for t-tests. Okay, so before you begin your statistical test, you have to decide if what you are going to do is a two-tailed test or a one-tailed test. Okay, so here's how most hypothesis tests work. So just an overview of the hypothesis testing process. We are to compare a certain obtained value from a certain type of test, t-test, analysis of variance test. So for the t-test, we have what we call the t-value. For the ANOVA, we have f-value and so on, and compare it to a critical value. It's a value that says there's a boundary, and if it exceeds or goes beyond, that means you have evidence to reject the null. So it's just to reject or to fail to reject the null hypothesis. So for this one, in this example, we have the critical value at this point, and 95% of all the values are true, and 5% of all the values would say that you can reject the null. So also we have to remember about our significance level. What is that? Your alpha or your significance level, if you still remember. So in most statistical tests, they have agreed to use 0.05 as a good enough level. So since that's alpha is equal to 0.05. If you want to be stricter, you can go to 0.01 or other than that. So it gets smaller when, for example, the implications are very important. For example, in medical type of researches. So most of us will just be using 0.05 significance level. This is the degree of risk that we are willing to take, that at this level, if it exceeds at this level, that means the difference that we found in our groups is not due to chance, it's not due to error, but of some variable, or the variable that we are speculating about. So that means, for example, the difference in the scores could be because of the way the children are taught, for example, or things like that. So we have this small chance of error. So this is the chance of committing a type 1 error. So we keep this very, very small para we can't be completely sure of all our decisions, but we have this leeway of saying at this level we are sure, at this small risk 0.05 we are sure of the other end of the spectrum. So you'll see later. Sige, so let's go to SLHT7, t-test for independent means. This is actually a small t. Okay, why do we have to use this? Well, we will see. We have this sample study. There are researchers named John and another John, and this SS Natawat. They had this study which compared the 297 Australian and 249 Indian university students. So just for example, class, this is an actual research. So I got this from the book of Neil Salkind, for people who think they hate statistics. So each student in this study was measured to take this eating attitude test, this one, and the Goldfarb fear of fat scale. And then the high scores on both measures indicate the presence of an eating disorder somehow. So they want to see that trend among these students. So yeah, they had these samples from the universities, and then they had to take the test, and then they were compared, and then the group scores were compared, and on a comparison of means, they had the means for both groups, and they compared the two groups. they found out that Indian students scored higher on both of the tests, and this was mainly due to the scores of the women. Well, the implications we shall see later. So the results of this eating attitudes test was found to be at the subscript 544 is equal to negative 4.19, comma, p is lesser than 0.01, and as well as this for the fat scale. So what just what all of this mean? So, parang numbers kay tanan, no? So, makita ninyo na later nga, unsa ni sila yung mga meaning aning small number here, and this number here, and this number here. So, in their study, they compared two groups, one from the Australian group and the Indian group. So, they're different, independent groups. And then, so, for this type of test, if you are examining, for example, let's follow this diagram first. Question: are you examining relationships between variables or examining the difference between groups of one or more variables? If you are examining between relationships, you go here, but let's just go at this side. You are examining the difference. So for our study, if there is a difference between the two groups. So if there is a difference, if that's what you want to know, next, are the same participants being tested more than once? Kapila ba? Nag-pre-test ba? Nag-post-test ba sila? So in our study, we had just one test. So no. And then, how many groups are we dealing with? We have two groups, the Indian and the Australian groups of university students. So two groups only. For more than two groups, that's another one. So for now, two groups ang example. So if you follow this line, two groups, that means we can use t-test for independent samples. So just to summarize, in that study, the difference between the groups of Australian and Indian students are being explored. The participants are being tested only once. They took the test once, no pre-test, no post-test. And there are two independent separate groups, and that would entail that the appropriate test statistic to use is the t-test for independent samples. What is this for? So the independent t-test is for number one, two independent groups, two groups that were tested only once, and you want to check the statistical difference between the means of either two groups or two groups of different, or two interventions or two change scores, and so on. So those are the examples. So in other sites, I found this one. The independent samples t-test is also known as these names. We have the popular one, independent t-test, independent measures t-test, independent two-sample t-test, student t-test, because the pseudonym for the one who made this one, who made this test was student. It is actually Fisher. So two-sample t-test, uncorrelated scores t-test, unpaired t-test, and unrelated. So unpaired and student t-test are commonly used, as well as this one. So basta makadungog mo ani nga names, parehas rin sila. Unpaired, student t-test, independent. So this is a parametric test. So we have conditions kung kanus apud ta makagamit ani. In this test, the variables used, we have the dependent variable or the test variable, the independent variable or the grouping variable. So what are the requirements? Let's just go over very few of this. Number one, you can use a t-test when the dependent variable or the result variable, the data that you are going to get is a continuous data, interval or ratio level, not ranking level, first, second, third, but continuous type of numbers. 1, 2, 3, 4, 5, 1.1, 1.2, 1.1, 2, 3, 4, and so on, or ratio level. Basta those kinds of numbers, quantitative numbers. For number two, independent variable that is categorical and has exactly two categories. So for the test, we had two categories. Category group, the grouping variable. So we have Indian group and the Australian group. So there are exactly two categories. Number 3, cases that have values on both the dependent and independent variables. Number 4, independent samples or groups, that is independence of observations. What is that? So number 1, there is no relationship between the subjects in each sample. So wala siya gisumpay, wala ni mo siya gi-pre-test, post-test na pod, and so on. So they are independent. No group can influence the other. They're very independent, or violation of this assumption will yield to an inaccurate p-value or other values that we will try to compare it with. Number 5, random sample of data from the population. This is very important. Random sample and well-representative sample is chosen. Number 6, normal distribution or approximately normal distribution of the dependent variable for each group or of the data that you got. So we have also test for normality. You can read more about this one. This can also be fixed by the other research design principles that we have discussed. And this one, number 7, homogeneity of variances. So the variance are approximately equal across groups. So when this one is assumption, this is violated, if the sample sizes for each group differ, the value would not be trustworthy. And we will just look at these other conditions later. And no outliers. Wala simang kayo, dako kayo nga value and so on. Because that could mean it is not normally distributed. For example, all the data that you got were just 1 cm, 2 cm, 1.5 cm ang height sa plant, or height change 3 cm. But katong usang plant kay naabot gyud siya 50 cm in one day. Grabe, nataas. So muna nga this one is an outlier in the group. So dili siya pwede mo gamit ani nga test kay it would be inaccurate. And note, when one or more of the assumptions of the independent t-test are not met, like dili siya normally distributed and so on, you can use other tests, or you may want to run this non-parametric test called Mann-Whitney U-test. For some studies, like in my research study, if gamay ra ang samples na kung nakuha, I was suggested to use this Mann-Whitney U-test. So this is similar for the independent t-test, pero para ra siya sa gamay nga sample. And also other tips, each group should have at least 6 subjects, or ideally more. Inferences for the population will be more tenuous with very few or too few subjects. And you have to have a balanced design. The same number of subjects in each group. Group 1, same, the other 2, same. Extremely unbalanced in designs increase the possibility that violating any of the requirements or assumptions will threaten the validity of the test called the independent samples t-test. And read further in this site. Okay, what else? What last assumption before we start? Note that the independent samples t-test in this material, we can only compare means of 2 and only 2 groups. Duha ra jud, comparing the means of 2 and only 2 groups. Basta malapas, lahi na dili na pwede gamitan og t-test. So it cannot make comparisons among more than 2. If you wish to compare the means across more than 2 groups and many other categories, you will likely want to run the test called ANOVA, which is for SLHT8. So karon 2 and only 2 groups lang ta. So how do we solve for the test statistic? We can run programs for this, but for this SLHT, I encourage you all to solve it by hand so that mas maka-interpret mo, no? Kay naka-experience mo, nakakita mo na inani day ang sulod sa iyang formula and so on. So here now is our formula for computing the t-statistics. The formula looks like this, and we got this from a book. The formula for computing the t-value for a t-test for independent means is shown here. Formula 11.11 in the book that I got. So the difference between the means make up the numerator. So these two, x sub 1 and x sub 2, or x bar sub 1 minus x bar sub 2, that is representing the mean for group 1 minus the mean for group 2. Next, so the amount of variation within and between each group makes up the denominator. What are these numbers here? So we got a bunch of things to plug in, and first we just have to find these values and then we will just place it here. So for the n sub 1 and n sub 2, this represents the number of participants per group, so you have to count n, or the sample size, or number of data elements that you got. So pila ka book sila in a group, as well as n sub 2. Next, this one, what does this represent? So S sub 1 is the variance for group 2. This is the standard deviation. S stands for standard deviation, and you just square it. Or if you have found already the variance, for example, you use a Microsoft Excel, and then you just solve for the variance directly, diretso na o S squared. So variance na siya. So if you found the standard deviation, remember this part ha, if you solve the standard deviation is square ninimo, but if you already solve for the variance, then just plug it in and no squaring. But for uniformity, find the standard deviation and then square. So don't be confused with this terminology. This is just the standard deviation and squared. If nakakuha na kag variance, kay nag-solve ka sa, or gitiwas ni mong solve pa dong variance, mauna na siya. Dili na mubalik na pug square. Kay gi-square na dyan ang variance. Mauna ang symbol sa variance. Okay? Sige. Let's have an example. Here are some of the data reflecting the number of words remembered following a program designed to help Alzheimer's patients to remember order of daily tasks. So we know that an Alzheimer's disease, the people suffering from it may fail to have a good memory. So they are trying to undergo a program. They're designed to help them remember the order of some daily task. Yeah, remember the order of daily tasks. Group 1 was taught using visuals. Next, group 2 was taught using visuals and intense verbal rehearsal. Ipakita, gi-rehearse, i-memorize, verbal, say it out verbally. Visuals plus intense verbal rehearsal. So group 1 versus group 2. And then these are the following data that they got for the number of tasks each person has remembered. Na ay naka-remember og 7, 5, 3, 4, 7, 1, 10 out of 10. So, sa group 1. Sa group 2, mauni yung data na na-found, naka-remember og 5, 4, 7, 6, 2, 4, 3, 2, and so on. So, you have to look at nga, na grupo na siya. This is all group 1 and this is all group 2. If you have a data set na wala pa na grupo, you have to do it yourself. Sige, let's go. So here are the famous 8 steps in computing the T-statistic. The T-statistic is the number that we are going to find for the independent t-test. Number 1, we have to state the null and research hypothesis. Unsa may atong goal, diri pod makita kung unsa nga type of test atong i-goal, kung two-tailed bata, one-tailed, and so on. So we can have, because it says, okay, we want to check if there is a difference. So if there is a difference. So as for seeing, just to ask if there is a difference, you can now state your null hypothesis as there is no difference Ay, nasayop. Oh my goodness. Nasayop ni siya. Null hypothesis is, let me check. Maybe this is a mistake. Oh, it should be equal. Sorry for this one. The group 1 and group 2 is just equal. But for the research hypothesis, the sample that we got, x1, x sub 1 and x sub 2 means are not equal. That's our research hypothesis or our null hypothesis. We just want to say that we want to check if. So we are going to revisit the formula and also since we are trying to see if there is a difference, so we can just say, is it a lesser or a greater difference? We are not specifying that, so that means it is a two-tailed type of test. Two-tailed. Okay, we just want to say na ay difference, pero wala ta ni ingon nga asa nga greater, asa may lesser, wala tay direction, so non-directional. Okay, next, number 2, set the level of risk or the level of significance or chance of type 1 error associated with the null hypothesis. So just for this study and for most studies, we will employ the alpha at 0.01 level. But it is really just on the decision of the researcher. Oh, sorry. 0.05. Ang kina-common nag-use class kay 0.05. 0.01 is very strict already. Then 0.05. Next, select the appropriate Tstatistic. Test statistic. So, unsa man mga test atong gamiton. Here. So, we had 2 groups. Yes, we want to examine the difference. There are tested ones and 2 groups. That means, yes, T samples or T test for individual t-test atong gamiton. Independent. Wrong spelling. Independent samples. Okay, next. Now, sunod. Compute the test statistic value. I-solve na dayon nato gamit ang atong formula. So, visit ta sa atong formula. You can copy this one, but first, you have to also organize your data. Okay, so as a review, ang atong gibuhat, number 1, you just have to organize the data. You got the mean, you got all those things. Before ka nakabuhat ato, you have to arrange the data. If it's given to you in this way, arrange na siya, very good. And then what else? You are going to count the n per group, pila ka buok data values in group 1, n in group 1, and n in group 2. Pila ka buok elements or sample size. Next, you have to get the mean. Yes, we did that. And also, once we got the mean, pwede muna siya atong pang x bar. X bar sub 1, x bar sub 2. Ay, sayop. Next, we have to get the standard deviation per group. Muna siya CS. Para mauna dayon to ang S square. If you want to get the variance, you can also do that. This is the S squared. But remember ha, basta naa na kay S, basta naa na kay standard, if you have the standard deviation is square. Pero kung nag-solve yun ka sa variance nga squared ra, ay nagbalik kag square. So if this is the variance, this is squared already, dito na multiply dire. So dili ka mo balik-balik og square. Where we are again? Here. Oh. Yeah. So mao to siya. You can get the mean, standard deviation, or the variance. And then you have those values, then you will now plug it in your formula. So for this one, our x bar sub 1 is this, and x bar sub 2, the mean for group 1, sa imo pag-solve, I will leave that to you. This is 5.43 ang mean. Ang sa group 2, ang mean nila kay 5.53. And then the n sub 1 is 30 participants, and n sub 2 also 30. And then here, this is the standard deviation. Standard deviation. And also for group, this is group 1 standard deviation, and this is standard deviation for group 2. And then, basta standard deviation ra yung magikuha is square. Pero if you want to solve, if you got the variance, ayun, nagbalik kag square. Kaya gi-square drum na po ang variance. Okay, so ibutang na nimo sa calculator, i-type nimo, or you can have programs like this website. Where? Like this one, Desmos calculator. You can use it, but that's not the one na akong gi-type diha. So you can go type that. Everything is placed in the right right place. So mauna nga human imong solve, makakuha kag t value of negative 0.137. So remember that in your SLHT on page 4, it is said that when a non-directional test is discussed, you might find that the t-value is represented as an absolute value looking like this. So, na siya gibutang nga t, na siya absolute t. So, that would be like t is equal to absolute of negative 0.137. So, that's 0.137. Wala gi-mind ang negative sign, but that is only valid for non-directional or two-tailed test. When it is a one-directional test, magmatter jud ang mga negative sign. So ayaw na lang nakalimtis negative sign. Sige, go. So remember, our obtained value is negative 0.137. So what's the next step? Naanatay t value. Now, we have to compare it to the critical value kung para ma-accept ba siya or dili in terms of our null. So, number 5, determine the value needed for rejection of the null hypothesis using the appropriate table of critical values for the particular statistics. Every type of statistical test na sila ginatawag ng mga table of values kung asa ang critical value and so on. So, for t-test, sa likod sa mga books, like this statistical book, naa sila sa kinalikudan. Kana makita mo nga daghan kay numbers sa likod. Yeah, if you can see that one is not focused. So naa na sa kinatumyan sa mga appendix, naa sila gitawag nga statistical tables. So pag basawan nimo taro, ang label for that is if corresponding ba siya sa type of test na imong gibuhat, kay kung sayop sayop jud. So for this one, we will look for a critical value on the t-test nga table. But before we go, we first have to do something. Unsa man? Naa na tayo obtain the value, we also have to have the degrees of freedom. Unsa man yung degrees of freedom? So, pila daw ang, it's like we're allowing it. So, it is approximating, or we are approximating the sample size of the type of, the groups that we are having. So, to simply say, determine the degrees of freedom, or DF, which approximates the sample size, but for fancy technical reasons, adjust it slightly to make it more accurate or outcome. So, ato siyang adjuston gamay kay there are possibilities nga na ay errors in the sampling and so on. So, for this one, the formula only for this one, t-test nga, ani nga type of t-test, ani siya? N sub 1 minus 1 plus n sub 2 minus 2, or just to simplify, gi-combine. I-plus nimo ang sample size n sub 1 o n sub 2 niya minusag 2. So, ato ganiha 30 to kabuk sa group 1, 30 kabuk sa group 2. Plus nimo 60. Unya minusan nimo 2 minus 2, that is 58. So, magbantay ta ni 58. Sige. Anya, unsa man? Adto na ta sa atong standard table. So it's I printed you this one. So how are we going to use this? This is the book, and then you have to check first. Okay, you have to establish that number 1, ang imong tanawon kay kuan, imong alpha kay 0.05. Unya naa tay DF nga 58. Is it here? Oh yeah. Oh, diri data magsulat. Ako mag-iandam ang PowerPoint para diring dapita. Ang na-solve ani is 30 plus 30 minus 2, that's 58. So, D sub F, ang answer 58. Degrees of, DF, degrees of freedom, 58. Ang alpha level nato kay 0.05, itong significance level. And what type of test is this? Only, kung na-check rata sa there is a difference or there is no difference, so, two-tailed test. You have to have these 3 important information so that you can check in the table. So, kani nga ako nigi-print sa inyo for t values needed for the rejection of the null hypothesis. Ingon siya how to use this table. Compute the t value. Okay, done. Now, compare the t value with the critical value, and there are rules. If the obtained value is greater, the null hypothesis is not the most attractive explanation. And for the observed differences, meaning there is a difference. And number 4, if the obtained value is less, so strong ang null hypothesis, and we only have a small evidence against it. So we have to have, para dapat malpalabuan nato si critical value. Pangitaon sa nato si critical value. Unsaon man. Una, diri sa kasibabaw. Is it one-tailed or two-tailed? It is, atong timaan, it is two-tailed. So, two-tailed. Ari ka magpili. Asa man ay imong significance level? 0.10, 0.05, 0.01. So, ari ta sa 0.05. Next, asa man nga degrees of freedom? TF58. So, ato na siyang tungudon diri. Ato na tungudon diri hantod maabot ta sa katungod niya nga 58. So, scroll lang nimo, tan-aw nimo asang tunguda. In most books, this is very accurate per number, but here ila silang nakuha na sila 55, ang next sa 55, nag-by 5 na, 60 na ang next. So, what to do? Ang buhaton nimo, we will choose the one that is closest to our sample size. Eh, dili ta magpili og lower kay, for example, 55. 2.04. Kay dako man siya og critical value. Very strict na pud siya. So, 58 man atong actual nga gipangita. So, mas duol si 58 ni 60. So, atong sample size nga 60. That's why we are here now. Si 60, itong kung anon be, comment. Wala, dili siya mag-click. Kani. Si 60. Unya, diri nga lane ni sa tunga-tunga. Two-tailed. Ug ni this one. Ya, padung ta diri sa ubos. Ya, padulong pagyud ta diri sa ubos. Asa pagyud. Hantod magtungod ta diri ni 60. So, here we are. Our critical value is 2.001. Lista na to na. So, compare dayon nato. So, yeah, we already did this one. Using the F and alpha value in the type of test, we are looking up the critical value in the t-test table, and we found out na walay 58. 58 man tong goal diari, but be closer to the actual sample size, so 60. And then nag-abot ta diring dapita, two-tailed man siya, 0.05. Abuto na to, so this is the critical value. Okay. Our obtained value is at 58 degrees of freedom. It is what? Negative 0.13. Negative 0.137. Yang atong critical value kay our critical value is for the t-test table, it is 2.001. So decision time, if the obtained value is more extreme than the critical value, so the null hypothesis should not be accepted. If, so that means na atay evidence nga i-reject na to si null. If the obtained value does not exist, dili siya makalabaw ni critical value, the null hypothesis is the most attractive explanation to the difference. So, yeah, null hypothesis ingon siya nga there is no significant difference di ay kung dili ka makalabaw. That means we are going to not really accept HA. Ang term is fail to reject HO. Fail to reject the null hypothesis. So nasayop ni sa direct dapita class, please give a correction on your material because the more technical term yun ani kay, we don't say accept the HA, we say we fail to reject the null. Because all of these tests is just about the null. Kung i-accept ba na to si null or i-reject ba na to si null or i-fail to reject. Sige. That's the term. So, unsa man di ay ang naganap ato, natay nakuha nga t-value of negative 0.137 or this one. And our critical value of 2.001. Mas gamay man siya sa 2.001. So, we don't have enough evidence against the null. So, it is not extreme enough. Dili siya strong enough to say that there is a difference between your group 1 and 2. Or, it is not extreme enough for us to say that the difference between groups 1 and 2 occurred due to anything other than chance. Or so maybe that could be some error nganong na a difference, but not other than that. So not because lahi-lahi og strategy man to, di ba? Ang pag-teach sa two groups. Other group is visual, the other group is visual plus intense verbal rehearsal. So dili di ay. So in this data lang. So we do not have a strong evidence to reject the null. So wala siya no significant difference. So failed to reject the null. Ang judgment failed to reject sa null H sub O. Okay, so what can we attribute to the small difference? Yeah, lahi-lahi is lagmin, right? Ang usa kay 5 point, dili man gyud sila parehas kay ag tan-aw nimo makita nimo ang numbers lahi-lahi man, and then when you solve the mean, ang usa mean sa group 1 kay 5.43, ang mean sa other group kay 5.53. What is the reason kay nganong lahi-lahi man sila? Though we tested na dili pud na significant na difference. Some of the reasons is that the sampling error or the variability in the participant scores also. And more importantly, we're pretty sure, but of course not 100% sure that that's what level of significance and type 1 errors are all about, right? So at the very small level, nga po chance nga sayop ta, but very very small level. So that the difference is not true to anything in particular that one group or the other experienced to make its scores better. For example, ato nga test nga lahi-lahi og strategy para mag-memorize sa mga daily task ang mga tao nga nag-suffer sa Alzheimer's. Sa kato nga example. So yeah, as a result, for these two groups, this T of degrees of freedom of 58. Ang obtain nato kay negative 0.14. P is lesser or greater than 0.05. So disregard lang this part. We will have, or if we have time, we will discuss about this, but ayaw lang sa ning p-value. Ang atong style kay katong mga critical value and so on. So the two groups do not differ because of the way they were taught. So no significant difference. But we can also interpret this one. Difference. Yep. So atong gamiton kay sayang. So it means the probability is lesser than 0.0, or the probability of this happening is greater than 0.05. So most of the time most of the time our null hypothesis is right. So yeah, wala tay great evidence to reject the null. So no significant difference ra ang two groups. Okay, so that was the t-test calculation by hand. You can use Microsoft Excel for that one, like this. Here is the t-statistic, and this is for the two-tailed one, and the critical value is here, and the one-tail is here. So ikaw la judge, two-tailed man to aso kani. So there is no significant difference. So see, even if it's in here also, kari lang tanga unequal variance, kay lahi-lahi man silang variance. Same gihapon, no significant difference. So you can solve it by hand or automate it here, but much better kung nakaagi ta sa solve by hand, kay makasabot ta ngano din yung mga mananapa diri dahan kay numbers. Makatan-aw ra ka, maka-judge ra ka, because you went through a lot sa pag-solve. Sige, so that was the t-test. So in summary, t-test is only for specifically t-test for independent groups. Na ba ko na-prepare? Okay. T-test for independent samples are only for kato siyang independent groups jud siya, tested only once, and only two groups, and all those other assumptions that we mentioned. So if more than two groups and more than two categories, lahi na pud siya. Ani na ta sa analysis of variance.